All right, here's the video for part 1. We're going to do numbers 1 through 5. So the front page of your review for the arithmetic sequences, or arithmetic and geometric sequences in series test. So we have to decide what type of sequence is it, and then if it's arithmetic or geometric, what's the common ratio or the common difference. A, I have negative 0.6, 0.7, 2, 3.3. So what you can do here, I'm going to just start by checking to see if it's geometric, because those numbers, it's kind of hard to see if it adds the same thing every time. I'm going to start with geometric. And remember, the way we decide if something's geometric or not is we would take this second number divided by the first number. Okay, so when I do that on my calculator, so I'll 0.7 divided by negative 0.6, and I get negative 1.16. Okay, so then if I need to decide if it is geometric, so I would then take the second pair of numbers, 2 divided by 0.7. And when I do 2 divided by 0.7, I do not get the same number, so therefore I am not multiplying by the same thing, and it is not geometric. So now I check, is it arithmetic? So when I do arithmetic, instead of I have to divide, I'm going to subtract. I need to see if there's a common difference. 0.7 minus negative 0.6. So let's see, I'll have 0.7 minus negative 0.6, I get 1.3. So then I check to see if I add, I'll just do adding here, if I add 1.3, do I get to 2? Well, 0.7 plus 1.3 is 2. So therefore, this is an arithmetic sequence. And the common difference is 1.3. All right, part B, 1, 4, 9, 16. Well, if I added here, 1 to 4 would be adding 3. Then I would add 5. Because those two are different, it's definitely not arithmetic. For geometric, to get from 1 to 4, I'd be multiplying by 4. To get from 4 to 9, I'm definitely not multiplying by 4. So it's not geometric. This is neither type of sequence. Part C here. 2187, negative 279, positive 243, negative 81. Because the signs are alternating, I can automatically say that this is not going to be arithmetic. All right, the arithmetic would not alternate signs. Now I can decide if it's geometric or not. Let's take negative 729 divided by 187. So negative 729. And that gives me the common ratio, that'd be negative 1/3. So now I'm going to check if the common ratio between the next pair of numbers here would be negative 1/3. And you can divide 243 divided by negative 729. And I get the same ratio, therefore this would be a geometric sequence. And the R value, common ratio here is negative 1/3. Finally, D. The signs stay the same, so it could be either or. Let's start with geometric again. So I'm going to take negative 9 divided by negative 6. I get 1.5. Okay, so now I'm going to take negative 13.5 divided by negative 9. And I get 1.5, so this is actually geometric again. So geometric with a common ratio of 1.5. All right, that's number 1. Can you identify what type of sequence it is and what the difference or ratio is? Number 2, find the first term of an arithmetic sequence whose common difference is 7 and whose 22nd term is 143. All right, first of all, arithmetic sequence. That's what it says we're using here. So we need to be able to determine that this is the formula we're going to use. So if I'm looking for the first term, I know the common difference is 7, and I know the 22nd term, a sub 22, is 143. Well, I actually have all the information I need to put right into that formula. I'm going to put the 143 in for the a sub n. That is a term I know. I don't know the first term, but and remember, I like to put the d in front. I do know the common difference is 7. The n here, the term number for 143 is 22 minus 1. So let's see, what's 7 times 22 minus 1? That is 147. So this is 143 equals a sub 1 plus 147. And all I need to do to get a sub 1 by itself is subtract, and I get that the first term is negative 4. And that's it for that problem. All right, some of my favorites. Fill in the blanks. I'm going to lower this problem here, just to give us a little bit more room. Find the missing terms. Now, you can use the above formulas, but here's how I like to do it. I like to just create my own little equation. If I'm starting at 8 here, I have to add, now this is arithmetic it says, so we have a common difference. I need to add one common difference plus 2 common differences. So if I start at 8, I'm adding 2 more common differences to get to 52. If I solve that for D, I can then fill in all the blanks. So I subtract 52, and I get 2D equals 44, and D is 22. So now I can add here. If I do 8 plus 22, I get to 30. Double check, plus 22 does get me to 52. Plus 22 again is 74, and then 96. So I have to add to go to the right. To go back to the left, I need to subtract 22. So 8 minus 22 is negative 14. And that's 3. So now that you know how to do it, if you need help on number 4, try it on your own, but then come back and see if you need help on number 4. So I'm going to do the same thing here. Now I have a term here. I'm going to add the common difference. 1, 2, 3, 4, 5, 6 times to negative 12 to get me to 468. All right, so I'm going to add 12 here, and that's 6D equals 480. Then I just have to divide by 6. So here my common difference is 80. Now I can just add 80 each time. Negative 12 plus 80 is 68. Plus 80 would be 148. 228. 308. 388. And then if I added 80, I do end up at 468. So hopefully you remember how to do those. You guys like those. We're good at them. Last problem for this video, number 5. We're given a sequence, 3, 7, 11, 15. Find the equation for the nth term. Now, it does not tell you what type of sequence it is. So you have to decide, this is arithmetic or geometric. So look here. It looks like I am adding 4 every time. So this is going to be arithmetic. If I'm writing an equation for the nth term, I'm going to use my a sub n formula. So here's what I have. I'm going to write it in simplest form. A sub n equals. So I take my first term, which is 3, plus my common difference of 4 times n minus 1. Now we just want to simplify it, which means get rid of the parentheses. So I'm going to distribute the 4, which is 3 plus 4n minus 4, which simplifies to be 4n minus 1. That is the equation for a sub n. Now I'm going to use that in parts B and C. So in part B it says find the 20th term. The nice thing about that, if I'm finding a sub 20, yes, I could go back up and use the whole formula, but I just found a formula specific to this equation, so I'm going to use it. 4 times 20 minus 1. 80 minus 1 is 79. So the 20th term in this pattern is 79. Now I need to find the sum of the first 24 terms. So if I'm finding the sum, I'm using this series formula. And the only thing about this series formula, or actually we'll just start. Let's start with it and we'll get to that question in a second. I'm finding the sum of 24 terms. The sum of 24, the 24 is the n. I know the first term. But the thing is, I need a sub 24 here. I don't know what a sub 24 is, so I have to go back and use this formula from up above and put 24 into it. So you need to go back and find a sub 24. Okay. I calculate that and I get 96 minus 1 is 95. So I'm going to put 95 in that formula. And then I can type it into my calculator. Okay, so I'll have 24 over 2. Or you can write 12, that's fine. Oops. times 3 plus 95. And it tells me the sum is 1,176. Lastly, express the sum of the first 501 terms using sigma notation. So sigma notation, you're going to need sigma here. We're finding the sum of the first 501. So that means my lower index is going to be 1. My upper index is going to be up to 501. Now what goes after the sigma is that equation we found in part A, 4n minus 1. That's your sigma notation. Now your calculator can do that adding for you. So we're going to type that in. If you have a different calculator, verify with your teacher that you know how to find sigma notation. On these calculators, you hit math and number 0. We have to use x as a variable. We're starting at term 1. We're adding up through term 501. And then we type our equation, 4x minus 1. And enter, and that is the sum, 502,503. Okay, that is the first video.